Hello, I'm Caitlin Brand, and I'm going to be helping present Team 23101 Vumbula Resources, Optimizing Exploration. So this is a interdisciplinary project that was created by me, Caitlin Brand, Camilo Soho Aguera, Ain Boss Orant, Sydney Kayasito, Lucas Brown, and Zubin Sumar. Myself and Zubin, we were the two engineering students on this project, and our other four colleagues are all based out of geosciences. And this project has been kindly mentored by Dr. Hervé Rouzeau and Dr. Dean Riley, as well as sponsored by a variety of organizations, including PDAC, the Prospectors and Developers Association of Canada, NGEX Minerals, a Lundin Group company, the University of Arizona School of Mining and Mineral Resources, as well as the Frank Arnold Award. So, with that said, let's jump into it.
We are facing a global challenge. On the current trajectory, we need to discover and extract 740 kilotons of lithium and 4.7 megatons of copper by 2030. And the first step to producing mineral resources is to explore and discover them. Past exploration was environmentally damaging and unproductive. We need to be responsible explorers, allowing stakeholders to use their natural mineral resources to build communal wealth. Current methods take decades and are cumbersome. While exploration in itself is inherently a challenge, finding dilute amounts of metal deep inside tiny parts of the earth using current methods is insufficient. We must be innovative and design new ways to find mineral deposits because the stakes are high. Our team recognized the need to accelerate responsible mineral exploration to meet global demand. And as part of the Next Generation Explorers Award (NGEA), an international competition hosted by the Prospectors and Developers Association of Canada, or PDAC, we designed and deployed a streamlined exploration program in Uganda, Africa. Currently, Uganda has zero large scale mines. It is considered in the bottom 10 countries in regard to the Human Development Index (HDI), and despite nearly a decade since it was last in conflict, it has not seen large foreign capital investments. Uganda is underexplored geologically and in a domain known for world class gold, diamond, cobalt, rare earth elements, and copper deposits. Using the scarce, publicly available data and a novel method of exploration, our team worked to overcome the exploration challenges.
So, realizing that geological exploration can be improved and optimized in order to relieve a lot of those bottlenecks early on in the process, Zubin and I engineered a new design that basically put together a lot of those factors that would later on weed out economic deposits. We put those early on in the process. We're integrating the downstream factors that can determine whether or not a deposit that is geologically has a lot of potential and has a lot of metal, and also be able to evaluate to make sure that it can actually be mined in a way that is profitable and in a way that is environmentally sound. So, previously in other forms of exploration, kind of the traditional route, mining potential and geologic potential are in two separate columns. And honestly, a lot of times mining potential is not even considered until geological potential has already been flushed out. In our new design, what we're doing is we're front loading a lot of the issues related to the mining potential in order to streamline that process in order to be able to create a prioritized exploitation plan. Okay, so how did this look in all reality? So this figure summarizes a lot of the work that our team did, and putting together both the geological and mining potential together. And the major challenge that we had and needed to overcome and design around was being able to integrate categorically different forms of data in order to be able to understand both the geologic and mining potential, and also be able to put those together, be able to understand the full region and the full breadth of what we were dealing with. And so this figure below simply shows a variety of signals from the MBAR region. Those are maps layered on top of one another, as well as 3D models of various signals that we were able to gather from the region. And through integrating all these different types of data and being able to reconcile the different categories of data, we're able to put together some priorities for the exploitation of the mineral resources in the region. And so that's what's shown here. And so we've put together three main priorities. The first two, those are in the lower part of that map, are pegmatite deposits. So pegmatites are a rare type of rock, and these are known to have tin, tungsten, tantalum, and minor bismuth, with an upside of having various other rare earth minerals and other critical minerals. And so the in this map, the brighter colors, they're going to be showing the more prospective areas. And priorities 1 and 2, we were able to determine not only by their prospectivity, but by looking at other geological features such as the structure surrounding them, that they would be the most favorable places to begin doing on the ground exploitation of these mineral resources. Up in the north, priority number 3 is a gold deposit with the potential for platinum group elements and various other base metals potentially. The reason that it's priority number 3, even though gold is technically easier to actually mine, is that there's a lot of other artisanal mining going on in the region. And we recommend that whatever company, whatever group goes in to exploit this deposit, it needs to help create an artisanal mining concession in order to earn the social license to operate in that area prior to doing major on the ground work. So, in addition to having these three prioritized targets, we're also able to use an analytical hierarchy process to be able to configure the best option for bringing materials into the mine sites, as well as exporting the produced materials from the mine sites to get it to market. And through that, we're able to propose this rail line going into Mbara and leaving through Kenya and through the ports in Mombasa. And so altogether, what we're able to do is we're able to not only identify these economic deposits, we're also able to identify the things that need to be done from a mining engineering perspective in order to actually make them feasible to mine.
Through partnering across disciplines and bringing a fresh perspective to otherwise antiquated geological exploration, our team has been able to engineer and deploy a new method of conducting mineral exploration. The results included three precious and base metal deposits and recommendations for exploiting this mineral wealth. In doing so, we have contributed to our global demands for mineral resources and empowered Ugandans to leverage their mineral wealth.